So here we're going to be looking at applying Pythagoras' theorem. Last week we looked at how to use Pythagoras' theorem if we're given a right angle triangle. So this week we're going to have a look at some circumstances where we might have to do a bit of work to work out in exactly where we're using Pythagoras' theorem. Okay, so just 5 examples we're going to look through. Hopefully then they'll correspond to a lot of the examples, a lot of the exam questions you'll see, and a lot of the questions on the work that I've set for you on this. So here we have a 50-inch TV, meaning the diagonal length is 50 inches, has a height of 24.5 inches. So we've got a height of 24.5 inches here. The diagonal length is 50 inches. That's what, when you get lengths of TVs, like if we say we had a 50-inch TV, it means the length from corner to corner, and we want to find out the width. We want to find out this length here. So I'm just going to call that X. I'm going to give that a letter, and the aim now is to spot, do I have a right angle triangle where I have 2 lengths and I'm trying to find a third? And I do. This triangle here. Okay, so we've got a Pythagoras' theorem to use because we've got a right angle triangle, 2 lengths, finding the third, as we talked about in the video last week. So my next step is to find out what the area of all my squares are. So here we've got a 24.5 by 24.5 square. So 24.5 times 24.5 is times 24.5 is 600.25. Here, that's 50 by 50, which I can actually do off the top of my head, but let's just make sure I'm checking on the calculator. It's 2,500, and this square would be x times x, so that's x squared. Now, this is the one we want to find. I know that it's x squared, but I want to know what number that is so that I can find out what x is. The second step we looked at last week, or the third step, was do I want to add or do I want to subtract? Which is the longest side in my triangle? Well, it's this side here. If I wasn't sure, it's opposite the right angle. So this is my biggest area. So to find this one, I need to take my biggest area and subtract the other, because these 2 areas should add up to make this one. So we're doing 2,500 take away 600.25, and we get that x squared is 1,899.75. Okay, so x squared is 1,899.75. I want to know what x is, not what x squared is. I don't want to know the area of that. I want to know this length. So I need to get rid of that squared by square rooting. So I'm going to do the square root of 1,899.75. Because I left that on my calculator display, I can just say, well, it's the square root of my answer. So that's the square root of 1,899.75. And my calculator tells me it's 43.58612, and so on. So roughly 43.59 inches. Okay, and that would be my answer for that question. Okay, so quite an easy introduction then to seeing how to use that. If we were confident using Pythagoras, it's quite straightforward to see how to use that question. The triangle is quite easy to see that line was drawn on. If it hadn't have been, I might have had to do a bit more work to spot that. Okay, on this next example, we've not been given a triangle at all, but we've been given some instructions, and quite often drawing a diagram will really help in seeing what to do in a question. So it says Mr. Pigott goes out for his daily exercise. He leaves home and runs 2 kilometers north. So if that's where I start off, going north, I'm going upwards, so that direction is north. I'm going up for 2 kilometers, and he runs 3 kilometers west. So that's north, east, south, west. So I'm going across this way by 3 kilometers, and because the compass points are perpendicular to one another, that is a right angle there. It says, how far is he from his home? So this was my home, that's where I started off. I went 2 kilometers north, 3 kilometers west, and that's where I am now. And I want to know what distance I am from my home. I want to know that distance first. I've got a right angle triangle, I've got 2 lengths, I want to find the third. I'm using Pythagoras' theorem. Okay, so my next step, same as always, to find the areas of all the squares. So this is 3 by 3, so that's 9, an area of 9 kilometers squared. This is 2 by 2, so that's an area of 4 kilometers squared. And x by x, so that's an area of x squared. Well, what's that equal to? Am I adding or am I subtracting? This is the longest side because it's opposite the right angle. So I'm adding my other 2 areas, so 9 plus 4, the sum of those 2 areas gives me this area. So this area, x squared, is 13. So if x squared is 13, then to find out what x is, I'm getting rid of the square root. Getting rid of a square by doing the square root, doing the inverse of squaring, which is square rooting, and I'm doing root 13. Let's see what decimal that is by using the SD button. It's 3.605551 and so on. So if I round that to 2 decimal places, 3.61. That next digit's a 5, that's why I'm rounding up. So 3.61 kilometers. Okay, and that would be the distance that I would have run altogether. Okay, third example. This time we're very clearly given a right angle triangle, very clearly given 2 sides, but I'm not asked to find the other length. I'm asked to find the perimeter. So this is more of a case of sometimes we might be able to see a shape and think, oh, I definitely want to use Pythagoras here. I can just tell. It's screaming out for me to use Pythagoras. A right angle triangle and I'm given 2 sides. I want to know what the third is. 5 times 5 is 25, so that's 25 meters squared. 13 times 13 is 169 meters squared. And this length here, I know nothing about. Well, let's call that x. So that's x times x is x squared. Is that the biggest area? No, this is the biggest area, opposite the right angle. This 13 is the hypotenuse, so this is my biggest area. These 2 have to add up to make this one. So to find out what this area is, I take my biggest area, 169, and I take away this here, 25. So 169 take away 25 is 144. I've got x squared is 144. So I'm getting rid of a squared by doing the inverse of squaring, square rooting 144, and I might know what that is without using my calculator. The square root of 144 is 12 meters. So I found out that length, that's 12 meters. The problem some people will have on this question is that they'll then just forget that that's not what the question asked them for. So I've done really well in finding out that that's 12 meters. I might want to add that onto my diagram just so it's clear on there for what I'm doing next. Then I'm going to go back and check my question. It says, what is the perimeter of the triangle? How do I find the perimeter of a shape? I add up the lengths around the outside. So we've got 13 plus 5 plus 12. And now we can see why I had to use Pythagoras, because I needed to find this length. I didn't have it before. I had these 2. I didn't have this third one. Okay, so 13 plus 5 is 18, plus 12 is 30. So my total perimeter is 30 meters. Okay, the fourth example is when we don't have a triangle that we're given. We have to find the triangle for ourselves. So here we've got asked to find the height of a trapezium. So I want to find out, let's call it h, this height here. Well, I've not got a triangle here. Can you see a right angle triangle in there? Hopefully you can. Hopefully the right angle triangle you're seeing is this one here. And the reason why that's so useful is this height that we want to find is this height here. So I've got a right angle triangle with a hypotenuse, because that's opposite the right angle, of 6, a height that I want to find of h, and a distance along the bottom here. Well, this whole distance is 12, that distance is 8, so this distance must be the difference between them, must be 4, okay? Because this distance here I know is the same as at the top is 8, and 8 plus 4 makes 12. So I've got my right angle triangle. Okay, sometimes what I might do is just draw this out separately, just to help stop me getting confused with where all the numbers are going, because then I want to get the area of my squares. So this is h times h squared, 6 times 6, 36 centimeters squared, 4 times 4, 16 centimeters squared. And again, for h squared, we need to say, is it the sum of the other two, or is it the difference? Am I adding or am I subtracting? Well, this is my biggest area, this 36. It's opposite the right angle. This is my hypotenuse. So this is my biggest area. These two add up to make 36. So this area, h squared, is 36. Take away 16 is 20. H squared is 20. So h, get rid of a squared by doing the square root. The inverse of squaring is the square root of 20. And my calculator tells me that that means it's 4.472135, so on. So h is 4.47, not forgetting my units, centimeters. That's to 2 decimal places. Okay, final example. I've got the triangle on the left is isosceles, so that means those two lengths are the same. I'm making a presumption that they're the same. I would be told that those are the two lengths that are the same, not these two. Okay, so that is also 30 feet. I want to find the area. How do I find the area of a triangle? The base times the perpendicular height. So I want to know what this height here is. Okay, if I don't know what that height there is, I can't find the area of my triangle. Well, I've just created a right angle triangle as well. This is a length of 30 feet. This is a length I want to find. Well, what's this length along the bottom? It doesn't tell me how this 10 is split. But because I know that these two lengths are the same, this is the same here. These are two identical triangles. They've just been flipped. So this must be split equally. These are each 5 feet. So, picking out that triangle, let's just draw a quick copy of it here. We've got a height of h, we've got a base of 5, and a hypotenuse, opposite the right angle, of 30. I can definitely use Pythagoras. So I've got two lengths, I want to find the third. It's 5 times 5 is 25. 30 times 30 would be 900. H times h is h squared. But what is that h squared equal to? Well, it's not the biggest area. These two would add up to make 900 my biggest area. So h squared here is 900 take away 25, or 875, meaning that h, the height, is the square root of 875. I could put that into my calculator and find a decimal for it. I'm not going to do that yet. The reason I'm not is because it's not my final answer. I want to keep it as exact as I can until I get the answer I'm looking for. I wanted the area of the triangle. So the area of the triangle is a half multiplied by the base being 10 here, multiplied by the height, which is this h, which we've said is the square root of 875. Okay, I could do half times 10 and know that that's 5, but let's just put it all into my calculator as it appears there. So a half times 10 times root 875. My calculator tells me that's 25 root 35, or if I turn it into a decimal, 147.90199, and so on. So it's rounding off to 147.90199. 0.90 square feet. Okay, and those are some examples of how we would find answers to Pythagoras questions in context. So mainly it's looking for a right angle triangle. And once we've found a right angle triangle, making sure we apply Pythagoras in the same steps that we would usually. Okay, so try some of the questions, let me know how you get on, and good luck.